Welcome friends. In the last session we have discussed Thevenin's theorem with problems having dependent source and AC source, where we have seen that when a network encounters a dependent source, then everything remains as it is except to the calculation of Thevenin resistance, where you need to connect a separate voltage source, preferably a DC battery that is injecting a current. Then the ratio of the magnitude of the voltage and current of the battery will be the Thevenin equivalent resistance. Now in this session we shall continue our discussion with some more topics. Now today, this part, we shall discuss superposition theorem with some problems having the network with encountering dependent sources. So let us proceed to our problem. So let us quickly recap what is superposition theorem. So it is that theorem is basically is applicable for those networks which must have two sources minimum. Two sources. So here we have one voltage source here and another current source is here. So we need to consider one source at a time, keeping other sources are off. So let us first consider 6-volt source. Okay, let us first consider 6-volt source. Now this is the current, this is the voltage source. Again it is a dependent source by this symbol. Now the magnitude of the dependent source is 2I1, that is the flowing through this 1 ohm resistance. That is the current flowing through this 1 ohm resistance. So whatever current will be flowing through the 1 ohm resistance, that will be twice the magnitude of this voltage source. Okay. So let us say we remove the current source. We remove the current source by open circuiting those terminals. By open circuiting those terminals, right? So we write. So since this is the open circuited, no current should be flowing through this. So whatever with the current is flowing should entirely flowing through from 6-volt source. It is injected, then it is flowing through the 1 ohm resistance, then it will be flowing through the 5 ohm resistance, and then through this dependent source it will close the circuit. So let us say we refer that current to be I1 Vs. Let us refer that current as I1 Vs. Why? Because Vs for voltage source and I1 is for the the dependence, the first source, right? So as this only one current is flowing, we can directly write the KVL. It is very easy. So let us mark the potential. So here it is plus minus 1 ohm resistance, then again 5 ohm resistance, again it is a plus minus. And as it is indicated in the problem, it is the dependent source potentials is totally plus minus. So these three potentials, this potential across 1 ohm, potential across 5 ohm, and this dependent source, these three are additive in nature. So that is exactly written. Now what happens to this magnitude? Because as already that this is 2I1, where it's I1, what is I1? That is the current flowing through the 1 ohm resistance. So whatever current flowing through this 1 ohm resistance, that twice of that value will be the magnitude of the dependent source. Now in this figure 5a, we are considering the current flowing through 1 ohm resistance is I1 Vs. So as a result, the magnitude will become 2I1 Vs. So if we write the KVL equation, it will be 1 into I1 Vs plus 5 into I1 Vs plus 2 into I1 Vs. So if you solve this, you will get 3 by 4 ampere. That I1 Vs will be 3 by 4 ampere. So this current, that means let us say that it is in the problem it is asked that what is the current flowing to I1 and I2. It is determined. So in the first figure we have considered I1 as I1 Vs, which is we have evaluated 3/4 ampere, and for I2 current which is same as that of I1 Vs, which is also is equal to 3/4 ampere. Now let us consider the second diagram, figure 5b, where we have considered 1 ampere current source active, and we have removed voltage source, then we are short circuited the terminals. Okay, we have removed the voltage source, then we have short circuited the terminals. Now this 1 ampere current source is, 1 ampere current source is getting two paths. It is getting directions. So one along 1 ohm resistance, another along 5 ohm resistance. So let us say that 1 ohm resistance is I1 CS. Okay, that is the current I1 for current source, and let us say this is I2 CS, that 5 ohm resistance, that is the current I2 for the current source. Now since this current direction is reversed with respect to the original mother diagram, so the polarity of the dependent source also reversed. Polarity of the dependent source is also reversed. So if you consider the KVL, or if you want to write the KVL of the super mesh, because 1 ampere source is present, so these two meshes can be considered as a super mesh. So let me figure out what will be the polarity of individual potentials. So this should be lower node is plus, upper node is minus, then it is minus plus, left is plus, right is minus, and then 1 ohm, right is plus, left is minus. So the potential drop in 1 ohm resistance and this dependent, so these two are in additive. So we can write 1 into I1 CS, that with that 2 I1 CS, they are additive. With that, who is subtractive? What is subtractive? Subtractive is 5 into I2 CS. So that is exactly written. So if you solve, 3 I1 CS is equal to 5 I2 CS. This is equation 1, or rather equation 7 here. So 3 I1 CS that will be equal to 5 I2 CS. Again, you can understand one thing, that these two currents, this I1 CS and I2 CS, will make up to this 1 ampere. So again you can write this equation, I1 CS plus I2 CS is equal to 1 ampere. So if you solve equation 7 and 8, you will get I1 CS is equal to 5/8 ampere and I2 CS is equal to 3/8 ampere. This, if you solve these two, then you will get. So for the second case, you will get this answer. So now if you write initially, you will get first current is 3/4 ampere, you got for the first case, and this is 3/4 here. And in the second case, you are getting 5/8 ampere, but in the opposite direction. with respect to the figure 5a, you see these two currents are opposite in nature. This current is flowing from left to right, and for figure 5b, this current is flowing from right to left. So they are opposite in nature. So that is why they must be subtracted. So the net current will be 1 by 8 ampere. 1 by 8 ampere, which is I1. And for I2, for the first condition, it is 3 by 4 ampere. It is flowing from left to right. Now for the figure 5b, it is also flowing from left to right. So it is solved by 3 by 8. So both the currents should be added, 3 by 4 plus 3 by 8. So which is equal to 9 by 8 ampere, which is I2. So they are solved. This is called the principle of superposition. Called principle of superposition. Need to consider one source at a time, taking its response, and then other source, then other time. Then you need, if you have the total response, then you need to add individual responses to get the total response. So it is the solution for this problem. Let us move to our next problem. We have again a superposition theorem. We have figure 6. Find the current I. What is the I? It is the current flowing through 2 ohm resistor. It is the current flowing through 2 ohm resistor. We have two sources. We have two voltage sources, two sources. One source is 30 volt source and another source is this 3 ampere current source. So let us solve one by one by applying same principle. So let us first remove 3 ampere current source by open circuiting it, right? So let us analyze this circuit. So since this is open circuited terminal, then no current should be flowing through this open circuited terminal. So this 30 volt source will inject some current which is flowing through the 6 ohm resistor, and after reaching at node X, it will getting two paths. After reaching it node X, it will getting two paths. Now one thing, that let us say due to 30 volt source, when 3 ampere current is not active, the current flowing through is I1. Through the 2 ohm resistance is I1. So in the mother problem in figure 6, that current flowing through the 2 ohm resistance is I. That is why this dependent current source is 8I. Now for the same reason, as per the convention of the dependent source, when the current source is not active, when only voltage source is there, then the current flowing through, let us say I1, flowing through the 2 ohm resistance. And due to this fact, the current source is 8I1. The dependent current source magnitude is 8I1. So with respect to node X, try to understand one thing. With respect to node X, this current is leaving, which is equal to I1. This current is also leaving, which is 8I1. So two currents are leaving. So that current must be 9I1. This current must be 9I1, right? This current must be 9I1. So 9I1 basically is nothing but 30 minus Vx by 6, because if you consider this potential is Vx, so the current flowing through the 6 ohm resistance, current flowing through the 6 ohm resistor, which is equal to, of course, 30 minus Vx by 6, and that is equal to 9I1. That is equal to 9I1, and which is, that is, you can solve Vx by 6 equals to 5 minus 9i1. 5 minus 9i1. Here this is equation exactly, that is Vx by 6 plus 9i1 is equal to 5. That is equation 9 for you. Now what is Vx? What is Vx? Vx is nothing but, you see, as for this path, these two resistances, Vx is this potential as well. You know, this is zero node or zero potential, this is also zero potential. So whatever current is flowing, that is I1 is flowing because of the potential difference between node X and this node, which is a ground node. Let us say this is ground. So potential existing between this node X and ground node is Vx. The difference is Vx. So this we can write, which is Vx, that is equal to Vx, that is equal to 4 into I1 plus 2 into I1. That is why we can write Vx is equal to 6I1. That is 4 into I1 means the potential drop across 4 ohm resistance, and 2I1 means potential drop across 2 ohm resistance. So now if you solve this, if you substitute Vx is equal to 6I1 in your equation 9, that is this equation, you will get I1 is equal to 0.5 ampere. So due to the 30 volt source, current I1 flowing through the 2 ohm resistance is 0.5 ampere. That we have solved one part, when voltage source is active and current source is not active. Now consider the second part, when we have this current source active, that is 3 ampere current source is active here, but voltage source is removed by short circuiting its terminal. Voltage source is removed by short circuiting its terminal. Here it is, short circuiting its terminal. So let us analyze this circuit. And let us consider this current flowing through through these 2 ohm is I2, right? Let us say the current flowing through the I2 is current flowing through the 2 ohm resistance is I2. So this current, the current flowing through the 4 ohm resistance, it must be 3 minus I2. 3 minus I2, right? Now as per this convention, just if this is I2, then it must be the dependent source magnitude is 8I2. So this current must be 9I2. This current must be 9I2. So this 9I2 must be flowing through the 6 ohm resistor. So let me analyze the circuit point by point. I want to represent, that is the current through 2 ohm resistance is I2. Just assume. Just assume, right? Now since this is I2, then the magnitude of the current source, is 8I2. as per the convention of dependent source. So because of that reason, this current, if you consider this node as a ground node, let us say this node as a ground node. So if you apply KCL at this node, let us say this node is G. So if you apply the KCL at this node, so this 8I2 and this I2, they are both are incoming. So what must be the leaving current? It must be 9I2 leaving, which is flowing through the 6 ohm resistor, So the current flowing through the 6 ohm resistor, current flowing through 6 ohm resistor is nothing but 9I2. So now if you apply KCL at node Y, this node, so KCL at node Y, we get, let us say this current is IYX. Let us say this current is IYX. As per the symbol, it is nothing but P minus I2. Why? Because 3 ampere here it is entering and I2 here it is leaving. That is why this current is 3 minus I2. Okay. Again, if we apply KVL, so let us see one by one. We need to consider these three only, then it will be solved. The potential drop across 6 ohm resistor, potential drop across 4 ohm resistor, and this potential drop across 2 ohm resistor. These three we need to consider. This loop really. So KVL, if you write, so let me say, you see the potential drop across 6 ohm resistor and the potential drop across this 2 ohm resistor, they are additive polarity because their polarity are plus minus, right? So let me write down 6 into 9I2, that is the potential drop across 6 ohm resistor, then additive 2 into I2, that is the potential drop across 2 ohm resistors, and with these two the potential drop across 4 ohm resistors is subtractive, so that is equal to, we can write 4 into 3 minus I2, that is this current, that is IYX. So if you solve this, you will get I2 is equal to 0.2 ampere due to the current source 3 ampere, right? So initially you have solved I1 is equal to 0.5 ampere. Now you have solved I2 is equal to 0.2 ampere when 3 ampere current source for 3 ampere source, and this one was for voltage source, that means 30 volt source. Now when you consider both the source acting simultaneously, then you must add their response. So it is 0.5 plus 0.2, that is 0.7 ampere. So the current flowing through, we can get, as per superposition principle, the I is nothing but 0.7 ampere. We consider first voltage source, we get response is equal to 0.5 ampere. Then we consider current source, we get the response as 0.2 ampere. Now if we add these two, we will get the total response 0.7 ampere due to the both the sources, and this is by using superposition theorem. So we consider one source at a time taking its response, and then we add remaining all responses to get the total response due to the all sources. So this is the problems. These two are the problems of various types using superposition theorem we have discussed. I am ending this part here. Again, I encourage highly everybody to practice more, to have the inner grip of the problems very well. Thank you very much. Let us continue the discussion in the next part.